Hi children, from today I am going to explain grade 10 state syllabus maths. Daily we are going to do one concept. Okay children? So the first chapter in grade 10 is real numbers. Is it right? Before going to real numbers, we have to know some system of numbers. Let us learn that. First one is, do you know what are natural numbers children? Natural numbers. Counting numbers are called natural numbers. Do you know counting numbers are called natural numbers? Whenever we start counting, whenever you play any game, whenever you start counting, from where onwards you will count? 1. Next, 1 after 2, 3, 4, 5. So, these numbers are called natural numbers. Natural numbers are denoted by n. So, what are counting numbers? 1, 2, 3, 4, 5, so on. What is the smallest natural number here? 1. What is the biggest natural number? Does not exist. How many natural numbers are there in the set? We have infinite natural numbers are there in the set. Okay. Next, whole numbers. Whole numbers means what? The numbers, whole numbers means all the natural numbers together with 0 are called whole numbers. All the natural numbers together with 0 are called whole numbers. So, whole numbers are denoted by W. What I told, all the natural numbers. So, all natural numbers you have to take and together with 0. Together with 0 means 0 also included. So these are whole numbers. The smallest whole number is 0. We cannot say what is the biggest whole number. How many whole numbers are there? Infinite whole numbers are there. We cannot count number of whole numbers. Next one is integers. Do you know what are integers? Integers means all the whole numbers together with negatives of natural numbers. Integers are denoted by Z. What I told, integers means all the whole numbers. All whole numbers you have to take together with negatives of natural numbers. What are the negatives of natural numbers? What are natural numbers? 1, 2, 3, 4, 5. Negatives of natural numbers means -1, -2, -3, so on. So what are integers here? All the whole numbers we have to take. Along with all the whole numbers, we have to take negatives of natural numbers. Okay. So integers are denoted by Z. Why integers are denoted by Z? Here Z means Jahlin. It is the German word. It is the German word which means numbers. Okay. That's why integers are denoted by Z. Here, what is the smallest integer, children? Can you say what is the smallest integer? Here, see 0. 0 is in the middle of positive integers and negative integers. So, all the positive integers are greater than 0. All the negative integers are less than 0. Here, what is the biggest integer? We cannot say. Why? Here 3 is biggest. Suppose you think. Next 4 will be there. Next 5 will be there. Next 6. So, we cannot say what is the biggest integer. Here, what is the smallest one? -1. When compared to 0, -1 is small. When compared to -1, -2 is small. When compared to -2, -3 is small. Still we have so many numbers. So, we cannot say what is the smallest integer. But we can say what is the smallest positive integer. What is the smallest positive integer? 1, 2, 3, so on. In this, what is the smallest? These are all positive numbers. So, the smallest positive integer is 1. What is the greatest positive integer? The greatest positive integer is, we cannot say because still so many numbers are there. We cannot say what is the biggest number. If you come for negative numbers, what is the biggest negative number here? Biggest negative integer? -1. -1 is biggest among all. What is the smallest negative integer? We cannot say. Okay, children? Next. rational numbers. What are rational numbers? The numbers which are written in the form of p by q. The numbers which can be written in the form of p by q, where p comma q belongs to z and q not equal to 0, where p comma q belongs to z and q not equal to 0. Rational numbers are also called quotient numbers. Rational numbers are also called quotient numbers. That's why rational numbers are denoted by q. So what are rational numbers? X such that x is in the form of p by q, where p comma q belongs to z and q not equal to 0. So what is the meaning of this? X such that x is in the form of p by q. Rational numbers are in the form of p by q, where p comma q belongs to z. That means p and q we have to take only integers. Belongs to z means what? Z means integers. And q not equal to 0. Then only they are called quotient numbers. They are called quotient numbers and they are also called rational numbers. Okay. So here examples of rational numbers are 5 by 8. Is it a rational number? Yes, 5. It is in the form of p by q. P and q are integers. What is the condition? P and q should be integers. Yes, both are integers. And q not equal to 0. That means denominator is not equal to 0. Next, minus 1 by 7. This is also a rational number. 0. 0 is also a rational number. Why? 0 can be written as 0 by 1 because 0 by 1 value is also 0. So it is in the form of p by q, where p and q are integers and q not equal to 0. Here p is 0. In the condition, what is the condition? Q should not be equal to 0. Next, minus 3. Minus 3 is also a rational number. We can write minus 3 as minus 3 by 1. But 8 by 0, it is not a rational number. Why? It does not belongs to q. That means it is not a rational number because it does not follow the property of rational number. It is, even though it is in the form of p by q, p and q are integers. But what is the condition I told? Q should not be equal to 0. But here q is 0. That's why we can say that this is not a rational number. So what we can conclude from this? All the integers are rational numbers. All the integers are rational numbers. All the natural numbers are whole numbers. See, all natural numbers will be there in whole numbers. But all the whole numbers are not natural numbers. Why? Why all the whole numbers are not natural numbers? Because in whole numbers 0 is there. It is not present in n. All the whole numbers are integers. All the integers are rational numbers because all the integers we can write in the form of p by q. Minus 3 by 1, minus 2 by 1, minus 1 by 1, 0 by 1. So we can write in the form of p by q. Okay children, did you understand? Here we have two types of rational numbers. Rational numbers are of two types. One is positive rational number. Next one is negative rational number. What is positive rational number? Positive rational number means if a rational number, in a rational number, if the numerator and denominator contains the same sign, then it is a positive rational number. For example, 5 by 8. What is the sign of 5? Plus. 8 is also plus. Both are positive. It is a positive rational number. Numerator and denominator should contain the same sign. Minus 3 by minus 4. It is also a positive rational number. Why? Because both numerator and denominator contains the same sign. Minus minus, if it is cancelled, again you will get 3 by 4. So what is positive rational number? If numerator and denominator of a rational number contain same sign, then it is a positive rational number. Negative rational number. What is negative rational number? if the numerator and denominator contains different signs. See here, numerator contains negative sign, minus. Denominator is positive. Minus and plus, both are containing different signs. So, it is a negative rational number. Okay, children, 3 by minus 4. This is also a negative rational number. What about 0? 0 is neither positive nor negative. 0 is not a positive integer, not a negative integer. Okay, children? Now, let's go to irrational numbers. Okay, before going to irrational numbers, can you say some examples of rational numbers? Here all integers will come. Okay. Fractions will come. All fractions comes under rational numbers. Decimals. Decimals means here we have terminating and non-terminating decimals. Okay. Terminating decimals comes under rational numbers. Terminating decimals means 8.34. Point after we have certain number of digits. We can count. So 8.34. How can you say it is a rational number? 8.34 can be written as 834 by, whenever we are removing the point down, we will write 1, and point after how many numbers are there? 2 digits. So 2 zeros. So 8.34 can be written as 834 by 100. It is in the form of P by Q, where P and Q are integers and Q is not equal to 0. Okay, children? Okay. Still, what will come under rational numbers we will discuss after irrational numbers. Next, we will go for irrational numbers. Okay, children? What are irrational numbers? The numbers which cannot be written in the form of P by Q, where P and Q are integers, which cannot be written in the form of P by Q. They cannot be written in the form of P by Q. Where P comma Q belongs to Z and Q not equal to 0 are called irrational numbers. The numbers which cannot be written in the form of P by Q, which can be written, they are rational numbers. Which cannot be written, they are irrational numbers. Okay. Examples of irrational numbers are, here non-terminating, non-repeating decimals will come under irrational, non-terminating, non-repeating. First of all, do you know, children, how many types of decimals are there? Terminating decimals, non-terminating decimals. We have two types of decimals. What are they? Terminating, non-terminating. Terminating means already I told you. Before only I told here. What are terminating decimals? This is the example of terminating. Point after certain digits will be there. Point after we can count how many digits are there, we can count. They are terminating decimals. Like 4.16, 3.1434, like that. Okay, children, these are terminating decimals. Next we have, in non-terminating, we have one more, non-terminating. In non-terminating decimals, we have two types. First one is non-terminating repeating decimal. Non-terminating repeating decimal. See, non-terminating repeating decimal means it won't stop. A point after, it will come continuously. We can't count the number of digits 1, 4, 1, 4, 1, 4. That means some digits will be repeated continuously. Here, which digits are repeated? 1, 4, 1, 4, 1, 4, 1, 4. Can we write this one as 3.14 bar? Yes, we can write this one as 3.14 bar. Okay, children. So, here, non-terminating repeating decimals means this type of decimals will come under non-terminating repeating decimals. Repeating decimals, or we can say non-terminating recurring decimals. And one more type is there, non-terminating, non-repeating decimals. Non-terminating, non-repeating decimals. What is the meaning of non-terminating, non-repeating decimals? Here, after point, here some digits are repeated, no? Here digits won't be repeated, but we cannot count the number of digits. It will continue so on. We can't write these numbers as bar. So these type of decimals are non-terminating, non-repeating decimals. Now, these non-terminating repeating decimals will comes under rational numbers. How it comes under rational numbers? Already in grade 9, you learned this type of sums. How you solved? Periodicity, period you taken and you find the value. At last what you got once you remember? P by Q value you got. So, the value of this, if you solve, you will get the value P in the form of P by Q, where P and Q are integers and Q not equal to 0. That's why non-terminating repeating decimals comes under non-terminating repeating decimals comes under rational numbers. Okay, children. Non-terminating, non-repeating decimals, we can't find the value in the form of P by Q. Can we find? Do we have any method? So, these comes under irrational numbers. Okay, children. So, can you give some examples of non-terminating, non-repeating decimals? Already I gave one example. So, 3.86729842 like that, so on. Pi. Pi is an example of irrational numbers. Some of the children have doubt that why pi is an irrational number. The value of pi is 22 by 7. We will take the value of pi 22 by 7. Is it right? Then it is in the form of P by Q, where P and Q are integers and Q not equal to 0. It satisfies the property of rational numbers. Then why pi is an irrational number? Pi is not a rational number. Actually, the value of pi is not 22 by 7. The value of pi is 3.14 something so on. It is given in 9th class textbook. If you see, you will find the value of pi. In 9th class textbook they gave. The value of pi is non-terminating, non-repeating decimal. So, we cannot write in the form of bar and it does not stop. After decimal, the digits does not stop. So, but why we are using pi value 22 by 7? The value of pi is approximately equal to 22 by 7. Not exactly, approximately. What is the meaning of approximately? Nearly equal to 22 by 7. That's why we will say that pi is an irrational number. Did you understand? So, irrational numbers are denoted by Q dash. Irrational numbers are denoted by Q dash. Q means rational numbers. Q dash means irrational numbers. So, from this what you can say, children? Does rational numbers comes under irrational numbers? Any rational number is an irrational number? No. Any rational number is an irrational number? No. And still some more irrational numbers are there. Already you learned in 9th class. Can you say? Root 2. Root 3. Under root non-perfect squares. Root 5. Don't take root 4. What is the value of root 4? 2. It is a rational number. Root 6. So, these are all comes under irrational numbers. Okay, children? Already you learned in 9th class how to find the value of root 2, root 3, root 5 by using long division method. Okay, children? So, these are all irrational numbers. Now, our topic is real numbers. Now, we are going to our topic real numbers. Real numbers are denoted by letter R. What are real numbers? Real numbers are collection of rational and irrational numbers. Real numbers are collection of rational and irrational numbers. So, real numbers are denoted by R. That means all rational numbers union and all irrational numbers. Union means both. Rational numbers and irrational numbers both comes under real numbers. So, real numbers are denoted by R. Did you understand, children? So, tomorrow we are going to learn exercise 1.1 sums. How to solve the sums of exercise 1.1. So, this is the introduction part of chapter 1. Did you understand, children? Okay, children. Thank you.